Pamoja hakuna tofauti, sisi sote sawa. Upendo ndio njia ya kuishi.
Hi guys, once again, welcome to the Be Audacious session 4. We have been having AIML series since the beginning of February, and we are excited to have you for yet another session. My name is Abigail Ndegwa. I'm a co-founder at Be Audacious. We are a team of 3 members. Unfortunately, one of us has not been able to join us. Her name is Ivy. She'll be in for the next session. But in the meantime, I'd like to give Newton the platform to introduce himself and for him to also give us a brief overview about what Be Audacious is all about. You get to understand us. Yes.
Hi everyone, I'm Newton. I hope I'm audible. One of the co-founders at Be Audacious, and I'm excited to be with you today. For those joining us for the first time, Be Audacious is a community-driven tech space dedicated to empowering developers, whether you're a tech enthusiast, innovator, through learning, collaboration, and building solutions. So our main mission is to bridge the gap between knowledge and real-world applications in AI, machine learning, among other emerging technologies. And we thought to make this possible, we thought it wise to launch several technical series covering areas like AI and machine learning. That is the current series we're in, web development, cloud computing, cybersecurity, and more. So these initiatives are designed to equip techies with practical skills, ensuring that we not only understand concepts, but also know how to apply them in real-world scenarios. So we are so excited to see our community grow and engage in these experiences. And I encourage you all to make the most of today's session and ask questions and actively participate. So we're all thrilled to have you here, and we hope this session adds value to your tech journey. Thank you. Back to you, Abby.
Thank you so much, Newton, for the wonderful introduction. And in the spirit of being audacious, we want to remind you that we will be having our own in-house session. That is where one of the community members will be free to give us a free session on AI and ML. It's still coming up. We will make sure to share it out once we have come up with a date. So be on the lookout for that. And remember to be bold, be audacious, and be you. We also have our partners with us, that is Geekstars. And on behalf of Geekstars, I'd like to invite Monica to tell us more about Geekstars. Karibu, Monica.
Thank you so much, Abigail, for giving me the platform. My name is Monica Wamuhu. I am one of 3 co-founders for Geekstars, which is a community that represents women in STEM. In light of that, we also have our own webinar series that goes on every Thursday. We are having Lorna Juma, who's the Oracle Academy Program Lead Africa tomorrow, who's going to be our guest speaker. I hope to see you guys there, and hopefully the link to that webinar will be shared in due time. And yeah, thank you. We've been partnering with Be Audacious for quite some time, and it's been very fruitful. So we are grateful for that. Back to you, Vivian. Thank you so much.
Thank you, Monica. And we look forward to having you guys also for the Geekstars session. And because in the interest of time and we'd like to respect your time, I'd like to hand it over to our speaker, Elizabeth Idera. Elizabeth and I actually go way far, and I'm excited to have her in this series. And yes, let's hear from her. Elizabeth, if you're in the meeting, feel free to unmute and speak.
Hello, hi, I hope you can all hear me. So it's true, me and Abigail go way back from high school to now. We're now building AI solutions, and I'm really proud of the work they're doing here at Audacious. I'll be your guest today, teaching you all about AI, chatbots, NLP, and RAG. So you can allow me to share my screen in a minute. Hope you can all see my slides. Abigail, say hi. You can see my slides.
Hi. Yes, I can see your slide.
So today we are going to explore the fascinating world of AI chatbots and how they understand human language. I'm especially excited to share with you a powerful approach called retrieval augmented generation, what you see here as RAG. Which helps AI system more accurate and reliable. Whether you're completely new to AI or someone with background knowledge, I've designed this session to be accessible while still providing meaningful insights into how these systems actually work. My goal is that by the end of our time here together, we'll have a clear understanding of what's happening behind the scenes when you interact with systems like ChatGPT, Cloud, or Bard. So, um, so I'm a data scientist, I'm a machine learning engineer. I'm also a student at the University of Nairobi. Worked with several organizations, and I'm also a community organizer for Google and Women in Data Science. So we can get to the meat. So here's our roadmap for today. We will start by exploring how AI understands human language. It's quite different from how we as humans process language, and understanding these differences will help us explain both the amazing capabilities and frustrating limitations of AI. Then we look at why AI sometimes get things wrong, particularly focusing on what is called hallucinations, where AI confidently presents information that is simply not true. Next, we'll explore RAG, retrieval augmented generation, which is a clever approach that helps solve many of these accuracy problems. We'll finally have a hands-on demonstration to help clarify and make you understand more. If there are any questions, feel free to ask in between. So we'll start with NLP, natural language processing. This is a branch of AI uh, that is focused on helping computers understand, interpret, and generate human language. Think about it. Human language is complex, filled with so many ambiguities, subtle meanings. Like when I say that movie was sick, am I saying that it was disgusting, or am I saying was it amazing? Based on context, tone, and current slang, teaching machines to navigate these complexities is what NLP is all about. Why does it even matter? It matters because language is our primary language of communicating, and if computers can understand language, you can interact with them more naturally. You experience it every day through Siri, Gmail suggestions to complete your sentences, Google Translate, customer service chatbot. You see, in each case, NLP is working to bridge the gap between how we communicate and how computers process information. Uh, so how do computers now understand our language? So unlike humans who understand words or concepts with meanings, computers need to break language down into pieces they can work with. First, there's something called tokenization, which is actually splitting text into words, parts of words or characters. For example, a sentence like "I love learning AI" will be broken down into "I love learning about AI." Then they also typically convert everything to lowercase and remove punctuation to make processing more consistent. Then it also reduces words to their root forms, which is known as lemmatization or stemming. So, for example, words like running, runs, rain, all get reduced to run. This process helps computers work with language in a more structured way, but it's just the first step. Next, computers need to represent these words in a way it can actually work with, and that means turning words into numbers. Um, Computers work with numbers, not words, so each word needs to be converted into numerical form. Early systems used to use simple approaches like one-hot encoding, which basically it's like giving each word a unique ID number, but this didn't actually capture any relationship between words. So now what we have, modern NLP uses what we call word embeddings, representing each word as a set of numbers, as a vector that captures something about its meanings. These aren't random numbers, they are carefully learned from analyzing patterns in a huge amount of text. The magic is that words with similar meanings end up with similar number patterns. So happy and joyful, or sad and depressed, would have similar representations, while happy and computer would be very, very different. Um, Similar to what you can see here in the visualization, the word kitchen, vanity, sink, they're all together. So they're closer in the vector space. And like a word like sink and bulb. Okay, sink and crust. This means the computer has learned something about even more fascinating, this relationship capture relationship between words. There's a famous example where if you take the numbers representing king, subtract the numbers for man, and then add the numbers for woman, you get something very close to queen. This means that competence have learned something about gender relationships, loyalty, and how these concepts connect, all just by analyzing patterns in text. These rich representations are a key part of why modern AI language have become so powerful. On to the next. This is the evolution of NLP. It has evolved dramatically over the decades. Um, for the first mid years, it was more role based. Humans would manually create roles. Like if the question starts with where, look for a location in the answer. You see, then we move to statistical approaches. Instead of hard rules, these systems used probability. What is the likelihood that the bank in this context means financial institution? Like they said, the river is near a bank. What are the chances? What is the likelihood that the bank in this context refers to the financial institution and the river bank? Then around 2010, deep learning approaches using neural networks started taking over. These systems could learn patterns from data much more effectively than previous approaches. Um, then the real evolution came in 2017. Attention is all you need, with the introduction of transformers architecture that used something known as attention mechanisms, which I'll show you in a diagram. This allowed AI to better understand relationships between words when even they are far apart from in a sentence. This breakthrough in 2017 is what has led to modern large language models such as GPT, BART, Claude, and all the others that you love using. So this is how modern AI models process language. Um, the key innovation here is attention. I know there's so much going on in this diagram, but the whole idea is attention. Where, unlike traditional approaches where they would process words one after the other, making it hard to connect related words that appeared far apart, transformers instead process all words in parallel and use attention to figure out which words should influence each other. For example, in the sentence, the animal didn't cross the street because it was too wide, what does it refer to? The street, not the animal. The animal didn't cross the street because it was too wide. Is it the street? It's the street and not the animal. The attention mechanism helps the AI connect it with the street, even though there are words come between them. These models have also learn product concepts. They might learn that Paris is to France, Tokyo is to Japan, recognizing that the country capital country relationship without being explicitly quoted. Um, that is what modern AI model can do. So for the next exercise, the next is an exercise where we'll try to think like an AI. Um, so I'll say a sentence, then you can try to break it down like an AI would do. So the sentence, the bank by the river is a good place for fishing. So the word bank could have multiple meanings. It could mean a financial institution, a side of a river, an incline, or to rely on something like banking and support. So how does a human know which meaning is correct here? Context. Words like river, fishing help us know that we are talking about river bank. AI now works similarly but uses statistical patterns it has learned. When it sees bank near words like river and fishing, it assigns a high probability to a river bank, unlike it would assign it to a financial institution. This example seems obvious to us, but language is full of these ambiguities. Think about words like run, set, get. They each have dozens and dozens of meanings. Understanding which meaning is intended in each specific context is fundamental. It's a fundamental challenge for AI systems. We'll get to the next part of the presentation because I think time is not on our side. Um, why does AI get things wrong? Despite their impressive abilities, AI large language models still make mistakes. We could understand why. First, they have knowledge limitation. They only know what is in their training data. If something wasn't there, they don't know it. They have training data cutoffs. That's why you're told my knowledge is only limited to October 2024. So they lack access to current information unless specifically designed systems to provide it. Now, here is where RAG comes into place. They also have reasoning limitations. They lack common sense that as humans develop through experiences. They struggle with complex logical reasoning. Mostly importantly, they don't truly understand information the way humans do. They are incredibly sophisticated pattern recognition systems, so they're always looking for patterns, not a way we could comprehend in human sense. So that's a limitation of AI. This is why AI can write a beautiful poem about love, but doesn't understand what love feels like, or can describe a base code in detail, but doesn't truly understand how to balance when writing one. See, that's the difference between us and the AIs. Um, so what are hallucinations? Um, one of the most concerning problems with AI is what we call hallucinations. When AI confidently generates information that is simply false. This can take different formats like factual errors, like stating incorrect dates, events, relationships. It could also be fabricated references, maybe citing books, articles, studies that don't actually exist, logical inconsistencies, making contradictory statements within the same response. Um, what makes hallucinations particularly troubling is that they often presented within the same confidence as accurate information. They typically no indication that AI is uncertain or making up certain things. It all sounds equally correct. This means that without external verification, it can be very difficult to know when an AI is providing accurate information versus when it's hallucinating. Why does all this occur? It occurs we need to really understand hallucinations. We need to remember how these AI systems fundamentally work. They are not retrieving facts from a database. They are predicting what words should come next based on patterns they have seen during trading. This is what we call tokenization. We predict the next word to come. So imagine if I start the sentence with the capital city of France is, based on what the AI has seen in training, it assigns an extremely high probability to Paris coming next because the pattern appears consistently in the training data. But what if I ask about something more obscure, where the training did contain clear patterns? The AI still generates what it thinks are likely continuations, but this might not correspond in reality. It's like pattern completion gone wrong. The AI fills in the gaps with what seems plausible based on similar patterns it has not seen, not with its actual true. Additionally, AI works in reality. It can't verify information as its real world. Can't explain when something is true versus when it's possible. And was likely exposed to both accurate. The problem is when training AI, it could be exposed to both accurate and inaccurate information during training. So it's hard to differentiate when it's mislead and when it's headed true. Um, Interactive exercise. I forgot what to put here, but look for
Sorry,
instances.
excuse Elizabeth.
Uh,
We have someone called Gerald who is unmuted and he's really distracting the session. Gerald, would you please mute?
I think he forgot about unmuting. About muting, I'm sorry. So I think we'll just continue now. Abigail, any suggestion?
You can just continue. We are kicking them off in a few minutes.
Now we can get to the meat of all this. We'll explore RAG, which involves retrieval augmented generation. RAG is a hybrid approach that combines two capabilities, retrieval and generation. So retrieval basically is finding relevant information from trusted sources. Then generation is creating natural language responses based on that information. The core idea is simple, powerful. Instead of relying on AI alone, like training AI has undergone, we connected to trusted and up-to-date data. The core idea is simple but powerful. So instead of just relying on AI, you can connect it with more information so that it can give you better responses. Um, think of it as the difference between asking someone to record everything versus letting them reference specific books or articles while answering. The second approach will most likely be more accurate and up to date. So RAG offers several benefits. One, improved accuracy by grounding responses in verified information, then greater reliability since the sources can be known and trusted, then they're more transparent about where the information comes from. And you can customize for different domains or knowledge bases. We'll go through the whole RAG pipeline. Then we can look at the code. So first you start by loading your documents, then you split them into chunks, then create better embeddings. After creating them into chunks, you need to change these numbers into embeddings. Remember, we say that computers understand numbers. So converting these chunks into numbers, this is now word embedding. and storing them into a vector database. Then when coming in from the query, first the system processes the user query to understand what information is needed. Then it searches it through, it converts the query into vector embeddings, so into numbers. Then it searches the vector database to see which ones match with the query. Then it retrieves the top chunks that are relevant to the query, then passes it into an LLM and gives you a response. Basically, that's the whole RAG pipeline. Hope the noise was not too much, but it passed by your head. So we look at vector database, where I say vector database is where you store your embeddings, and embeddings are word representations of text. It's a key component of RAG. And this is where vector data, remember those word embeddings once more we had discussed, representing words as sets of numbers that capture meaning. We can do the same for the entire passages of text, creating what we call embeddings or vectors that represent the meanings of those passages. When you ask a question, the question also gets converted into vector, then the system finds the passage whose vectors are most similar to your question, meaning they're semantically related, even if they don't use the exactly same words. Evaluating RAG. How you basically evaluate RAG is looking, if you give it a prompt from your trusted sources, is it returning the same answer or coming up with answers? That's one way to look at it. It's known as factual correctness. There's also answer relevance to the original question. Is it relevant, or it's just giving an answer? The hallucination rate can, after giving it a prompt, you can check how did it hallucinate, did it create false information and whatnot. For retrieval performance, these are technical metrics. Precision recall, for those who are data scientists have probably come across these terms. It will look at how many retrieved documents were relevant and how many relevant documents were retrieved. So that's precision, false positives, true positives, yeah. Then mean reciprocal rank, how high the most relevant documents appear in results. The normalized discounted cumulative gain is how well the ranking of retrieved documents matches ideal ranking. From a user, looking at from the user side, user satisfaction through maybe surveys or ratings. Then there's the query resolution rate. How often do users get information they need? Then time to answer. How quickly do users receive the useful information? Could get to the demo. Are there any questions so far? So I don't know if we should start with the code, then the demo, or should start with the code. So we'll have a look at the code to see what actually goes on behind. So we started with loading the documents. We have various libraries that could help you do this. I'll share the code so you can have your own time to look at it. LangChain is very resourceful in providing all these libraries. So you could load your PDF, your text loader. After loading the document, you split it into chunks. We used recursive character text splitter. Then after splitting it into chunks, you create embeddings. There's so many embeddings you could use. You could use Hugging Face. You could use OpenAI. You could leverage on Together AI to use Mistral. So many of them. The beauty about AI is you explore and new tools are coming out every single day. After creating embeddings, we need to store them into a database. You could use Chrome, there's Pinecone. There's so many tools you could use. Don't worry about the code. I'll share it on GitHub so that you can explore it and build with it. Then adding an LLM. Then we could look at, is there a difference between RAG responses and standard LLM responses? That is what my demo is all about. So it has sample documents that I had inputted already in the background. You could also drag and drop a file from your database. Yeah. So we could query a question, maybe tell me about the recent climate agreement. This might take time. But if you're ready to start building some of the popular libraries and tools and frameworks you could use, you see it's loading the sample documents, then creating a vector stock with chunks, and then there's the LLM response, and there is our response here. As per my update in October 2023, this is one of the limitations we talked about, the knowledge cutouts. So it's only limited to where it was last trained. But you see, when you add more context, it's able to pull knowledge from recent knowledge, like now ours is from Global Climate Summit in Nairobi on November 2023. So he is one of the use cases. But for RAG, there's so much you can do with RAG, especially if you're working for enterprises or companies and you have company data that your company is the only one that needs to know. So you train your RAG about your company data, and everyone is happy. And you get up to date or information that is not on OpenAI in your chatbot. Yeah. I'll share all the resources, the demo in the GitHub. I'll share the file with Abigail. So I think that's all. I'm open to questions. Don't hesitate to ask about anything we've covered today, whether it's about fundamentals of NLP.
Thank you so much, Elizabeth. I can see there's a question in the chat section. So one of them is asking, so what is launching for? And then we can have Judy ask the question.
Can see more questions are coming up. LangChain is basically a library of framework designed for building applications powered by LLMs. Like OpenAI, it provides tools and integrations that make it easier to develop AI-driven applications, particularly those that require reasoning, memory, and retrieval. Like in our use case, we had we got LangChain text splitters. We use recursive text splitter. You see that is helping us split the document into different chunks. So basically, it provides tools and integrations that can make it easier to develop AI applications. Yeah.
We have another question, which states, how can RAG be used in building AI agents? Feel free to comment about the AI agent as well.
I feel like the future is AI agents. That is where we are moving. I was having a conversation with my friend who is here, who doesn't want to say hi. So the whole idea about AI agents, first we could start with what are AI agents. For those who don't know, AI agents are autonomous systems that can make decisions, interact with the environment, and perform tasks. Like now you specify an line to a certain task and give it, this is what you do, this is what we expect as output. Instead of generalizing it, you like specify you're an AI agent for article writing and tell it this is what is expected from you. Um, the other question was, can you use RAG for AI agents? I think you could give AI agents context. I think they would be more robust. Yeah.
Judy, feel free to unmute and ask your question.
Okay, my question is on now how do modern AI chatbots handle an ambiguous user who's asking queries, and what techniques improve their contextual understanding?
How do modern AI chatbots handle ambiguous user queries and what techniques? Because we talked about ambiguity and it's something that AI struggles with. I think they have several strategies. Sometimes it asks for clarification. When you say, tell me about Python, sometimes it would ask you, do you mean Python, the programming language, or Python, the snake? Sometimes they use memory and conversational context. When you're talking, if you are talking about Python, the language, there's no way to assume that it's Python, the snake. And sometimes guesswork and sometimes hallucination. Once more, they give you an answer that seems true, but it's not true. I hope I've answered your question.
Hello. So I had asked two questions and I don't think they've been answered. So my first question was, are you using OpenAI models or LangChain for embeddings? Because in the code I've seen, under your comment on embeddings, you've called OpenAI, and I can also see you've also used LangChain just before that. Yeah. So which one did you use?
I used OpenAI embeddings, which come with the API key. Once you pay for the API key, you have access to the large language model. You also have access to the embeddings. There are also other embeddings models you could use that you don't have to pay for. You could use like Hugging Face. Hugging Face has very nice embeddings. And with the time, you'll know how to optimize each stage. Okay, with practice and you'll know how to embed each, how to make each phase of the RAG process better. I've seen a question in the chat on graph RAG. Have I answered your question, Lance? Yes.
Yeah, ish. So what was LangChain for exactly?
LangChain is a framework designed for building AI tools. So it gives you access to all these text splitters, PDF loaders, that actually help you to develop those AI applications. When you go through the code, I think you'll have a better interpretation of what LangChain does.
Thank you.
Seeing graph RAG as an improvement of RAG, any ideas or info on this as someone who is already building? Second, how does RAG affect API input and limits? Graph-based retrieval augmented, that's RAG, is an advanced approach to RAG that enhances knowledge retrieval by structuring information as a graph instead of using the traditional vectors that I've shown you. I think I don't want to limit you to what you need to learn and what you don't need to learn. I think learn all, because in different use cases, some are better than the other. Yeah. Mm. Thank you, Isaac. Love to hear about how your team integrated it into MVP. could you share some insights on its application and impact? Well, the tool we built was Podcastify, which essentially, once you input documents into it, it provides a podcast. Basically, what Google Notebook LM is doing, but we used an open source bit of it, which is also in GitHub. Maybe you could look into it. It's open source. Yeah. What open source alternative models do you use, both from LLM to embedding, that are as efficient as the closed models? Llama has open source models. You can access them through Grok. I think I'll also add that into the resources. Please have a look at the resources. I'll make sure I add all the open source models that you could use for both for embedding and for the large language model. Yeah. What is the accuracy of your chatbot? I want you guys I want to use user based to check if my chatbot is actually accurate. Maybe 98%. Yeah. I'll share my GitHub. I'll also share the link to the resources. The hand is just up. You can proceed, Abigail.
Okay, I think she forgot to put it down after she had asked. Thank you so much, Liz, for joining us for this session. We'd love to have you for another session. And in the spirit of being audacious, because that is what we are campaigning for, we have been encouraging our community members to participate in hackathons. And we were requesting, if possible, you could give them the go-tos and what to expect, what not to expect, what to do, what not to do during the hackathons, because there's one that they have been applying for and they were asking for some advice on the same. Yes.
Well, hackathons are a very nice avenue to learn. I keep saying go with an open mind. Maybe the prize money might be looking too good, but this is your chance to learn from people who are as smart as you are. Sometimes you go in as teams, sometimes you go in as an individual, then you have to form teams. So, what was the question again?
You can tell them what to expect, how it's, basically just advise them in terms of hackathons, because most of them, it's their first time going to a hackathon. And yeah.
Well, ideally, some they're not really the same. Some are different. Some are more intense. Some are time constrained, unlike others. But for most, time is restrained, and it's really intense. You'll need to work quickly, think on your feet, and adapt to challenges. You might also need to work with strangers or friends from different backgrounds. So you need to really communicate well, and assigning roles. I think assigning roles is very crucial. Like who is doing what and when and how and what's the timeline. So that's really essential. Sometimes you may need to learn new tools on the fly or adjust your tech stack based on resources. So you need to be very, very flexible. And sometimes sleepless nights or somehow close to it, depending on the hackathon's duration. You might have to sacrifice sleep to complete your project. Maximize productivity without burnout. And you'll get amazing mentors, because most of these hackathons are organized by well-established people in the AI in all these spaces. So you'll get a chance to network and learn from professionals. Sometimes you might have started with this idea, then midway you feel like it's not good enough, and you need to change it. So you need to be as agile as possible and welcome to feedback, because the goal is learn and also win at the same time. Um, After doing all the code, you need to now present it to judges. A strong presentation goes a long way. You need to showcase a working demo and a working, not the ones that, oh, it was working on my laptop. No, a working one. Then judges will maybe assess innovation, then feasibility, maybe execution, how is it executed, and potential impact. Then something that they're really looking at is inclusivity. Now that you're building in AI solutions, make sure you input that or voice feature that, someone who is blind or blind can input voice or input, get for meaning voice outputs. Then there's rewards even beyond winning. Even if you don't win the hackathons, they will provide very nice networking opportunities. You could meet your next employer, you could meet your co-founders, investors, then skill building, and maybe some of those projects turn into portfolio pieces. So I would encourage you to go with an open mind, look at it from a perspective that you're networking, you're building your skills, you're building your portfolio. So that is all you need. I don't know if there's anything I could add.
Thank you. Thank you so much for that. And I think now our members are now audacious enough to go apply for those hackathons and go with an open mind, as she has said. For now, I'd like to return the meeting to Newton, who will finish it up for us. We have been excited to have you guys and see you next week. But let's hear from Newton.
So before I give my closing remarks, I know most of you might be disappointed, but we plan to wrap up with a quiz, and we sincerely apologize for this. We know many of you are looking forward to it, and we appreciate your patience. Though to make up for this, we're working on introducing weekly challenges instead. These challenges will be shared after every session, allowing you to apply what you've learned in a more practical way and interactive way. So stay tuned. And to the vote of thanks, that was such an insightful and thought-provoking session. A huge shout out to our speaker, Elizabeth Waithera, for guiding us through the fascinating world of NLPs, that is natural language processing, retrieval augmented generation, and chatbot technology with such clarity and practical insights. We also want to extend our heartfelt gratitude to our collaborators and our friends from Geekstars for being an integral part of this initiative. And of course, the biggest thanks goes to each and every one of you, our amazing attendees. Your curiosity, questions, and enthusiasm is what brings these sessions to life and make them impactful. From the chats, for those who want to revisit today's content, all links, including the session's recording, the speaker resources, and any upcoming challenge, as well as the next events, will be shared in our community channels. They have been shared over the chat. Additionally, for those who registered for this session, you will receive all the links that will be shared through and by Elizabeth via your emails. So be sure to check your inbox and also check the WhatsApp channel. Before you officially sign off, let's stay connected, keep the momentum going, and join our community to stay updated on future events, discussions, and exciting learning opportunities. So I hope I haven't locked anyone out. And with that, thank you for your time, your passion for learning. Keep pushing boundaries, keep building, and most importantly, stay audacious. We can't wait to see you all in our next session. That is same place, same time. Yeah, thank you for your time. You're free to leave.
Golden streams flowing strong and true.